Today we will discuss the topic application of derivatives part 2. So previously we discussed the basics of application of derivatives, in which we use the basic formula fx plus h equals to fx plus h f dash x. So this is the formula by which we will collect the approximate values of the functions. So this is the approximation method, and this is very useful for physics point of view or any type of calculations. So this is the formula in which we have any function, any type of function. Maybe the root x is a function, you want the value of any number which is in root, maybe the cube root. It is very difficult to calculate by other methods in arithmetic way. So this is the easier method, but the value will be approximate, not the exact value. Maybe we can collect the reciprocate value, maybe we can collect the value square in reciprocations, 1/4 power. So it is very difficult to calculate mathematically, but by using this formula it is very easy, right? We can also collect the sine x, cos x. So we know the standard values, just like we have sine 30, so easy, we know the value. But if we want to collect the value of sine 31 degree, so it is difficult. So like in these cases we will use this formula, and this makes easier to calculate the value, but the value will be approximate. So sorry, not the exact value. If you want the exact value, so like these trigonometric functions, you should use the lab manuals in which the last page is related to tables, so you can collect the values from there. Right now we will get the approximate values of these exponents, maybe the exponential functions, maybe the log functions, or the trigonometric functions. So we can collect these. Find the approximate value of under root of 0.037. This is the decimal value, right? So we want to collect the approximate value of this. So we will use the formula fx plus h equals to fx plus h f dash. So the formula is this. We will use this formula and to calculate this value. So in this we should select the value of x, that is 0.04, and value of h will be minus 0.003. Why we are taking it minus? Because the required value is lesser than its assumed value. This is 0.040 and this is 0.037, so it is lesser value. That's why the variation is minus 0.003. So put the value of x and h in this formula. So the function is exactly the root of value. Fx plus h is root of x plus h, means with variation, and f dash x, the derivative of this function, is 1/2 root x. So put these values with x and h in this expression. So this is root x plus h equals to root x plus h f dash x is 1/2 root x. So place these values, you get 0.037, this is 0.04 plus with variation 0.003 and 1 over 2 root of 0.04. So this value is 0.2 and this is 0.003 divided by 2 into 0.2. So it is 0.2 and this is 0.003 over 0.04. So this is 3 over 400. We get the value, it is 77 over 400. So it is 0.1925. So this is the answer of the value 0.037. So the under root of 0.037 is 0.1925. So it is very easy to calculate this. If the function fx equals to 3x square plus 15x plus 5. So find the approximate value of this function at 3.02. This is not the integral value, so it is decimal value, in which we will collect x as 3 and the variation h is 0.02. So function is this fx plus h equals to fx plus h f dash x. So the derivative of this function is 6x plus 15. So put these values of x and h in this function. So f3 plus 0.02, this is f3 plus variation is 0.02 and differential is f dash x is, so it is 6x plus 15. So put the value of x as 3. So you will get f3 means 3 into 3 square plus 15 into 3 plus 5. This is the value of fx. f3 is, put x as in this expression, so it is 3 into 3 square plus 15 into 3 plus 5. So you will collect this value, that is 77 on addition this. And what is f dash 3? So it will be 6 into 3 plus 15. So it is 18 plus 15. So we will get, so put these values in this expression. So you get this plus 0.02 into 43. It is 33, sorry. It is 33. So this is 77 plus 0.66. So answer is 77.66. This is the value of function at 3.02. So this is the answer. If fx equals to 1 over x square, or you can say find the approximate value of 1 over 2.02 square. So it is the function is 1 over value square, a variable square, so it is 1 over x square. So the solution is fx plus h will be 1 over x plus h whole square, and function is fx, it is 1 over x square, and f dash x is minus 2 over x cube on differentiation. So put these values in this expression. So we get 1 over x plus h whole square, 1 over x square plus h into minus 2 over x cube. So compare this with this. So x is the integral part, that is true, and h is the variable part or variation, that is 0.02. So put x as 2 and h as 0.02. So put these values in this expression. So 2.02 square, this is 1 over 2 square, h is 0.02, and this is minus 2 over 2 cube. So you get 1 over 4, and this is cancel out. So this is 0.02 over 4, LCM is 4, so 1 minus 0.02 divided by 4, so it is 0.98 over 4. So cancel out this 0.2, and it is 4 and 5. So this is the answer. So using the differential method, we will collect the approximate value of 1 over 2.02 whole square. So it is this value. Find the approx value of 4th root of 15, or you can say 15 raised to power 1 by 4. So function should be x to the power 1 by 4. So fx plus h will be x plus h 1/4, and the derivative of this function will be 1 by 4 x to the power minus 3 by 4. So this is the differential formula. Put all these in this differential formula. So it is x plus h 1/4, x to the power 1 by 4, h into x to the power minus 3 by 4 over 4. So put x as 16 because 16 is 2 to the power 4. So you can collect x to the power 1 by 4, means you can collect 4th root of 16 easily, that is true. And h is your required value is 15, but you are taking x as 16, so it is lesser value as compared to this, and this is one short, so this is the -1. So put these values in this, so you get 16 minus 1 1/4, and this is 16 to the power 1/4 plus h is -1, and this is 1/4, and you can take it as with positive power, so it is 16 to the power 3/4 positive power in denominator. So it is 2 to the power 4, and this is 1/4, and this is -1. 4 into 2 to the power 4 into 3/4, so cancel out these, so you get 2 minus 1/4 into 2 cube. 2 cube is 8, so you get 2 1/32, so it will be 64 minus 1, it is 63/32. Find approximate value of log (10.02) on the base e, natural base, and it is given log 10 to the base e is 2.3026. So find the value of log 10.02 to the base e, natural base. So function is log of any number, log of any variable, so it should be x. So the derivative of this is 1/x, and fx plus h is log e x plus h. So we want the value of this, so fx plus h, fx plus h f dash x. So this is log of x plus h, this is log x, this is, and it is 1/x. So compare this with this, so the complete number is x, and the decimal number is as h. So x as 10 and h as 0.02. So put these values in this, so we get log 10.02, and this is log 10, and this is 0.02 with 1/10. So the value of log 10, it is given 2.3026, and this is 0.02 divided by 10, so we get 2.3026, and we get 0.002. So add this, we get 2.3046. So this is the value of log 10.02. This is your answer. Next question. Cos 61 degree. Find the value of cos 61 degree, approx value. And the given is sin 60 degree. So sin 60 degree is 0.8 0.6603, and 1 degree is 0.01745 radian. So this is the question. You want to collect the value of cos 61 degree, and this is the approximate value, and given value is sin 60 degree, it is 0.86603, and the 1 degree is this 0.01745 radian. So function is cos, so fx is value of cos, so cos x. So f dash fx plus h is cos x plus h, and f dash x is minus sin x. So we have the differential formula, fx plus h equals to fx plus h f dash x. So put all these values in this expression, we get cos 61 degree, cos 60, (1 degree) or minus sin 60 degree. So we want to collect this value cos, so x is 60 degree or h is 1 degree. So we put these values in this expression. So it is cos 61 degree is cos 60 is half, or you can say 0.5, and this is 1 degree. 1 degree in radian is 0.01745, and minus cos sin 60. Sin 60 is 0.8603. So multiply this, and we will collect the value .4849. So it is on multiplying this, it is 1, 5, 1 and 5. So when you multiply this, you will get this. So this is value of cos 60, and this is 1 degree, and this is sin 60. So you multiply this with negative sign, and when you subtract 0.500 with this, you get the answer. So it is cos of 61 degree. Thanks.